Okay, finally, the whole point of doing, the major point of doing the distance formula and revisiting the Pythagorean theorem has to do with finding formulas for circles. So, definition, a circle is a set of all points in a plane that are a distance r from some point hk. So, HK would be the center of the circle, and R is the radius of the circle. Right, so that's a formal definition. It has to be in a plane because if you're in space, that would be the definition of a sphere. So that's why that fits there. Okay. It also tells us that we have two variables, which we usually would call x and y. And for a sphere, we'd need x, y, and z. Okay, so there's a circle. I know you knew what a circle looked like. The center, of course, is not a point on the circle. It will not satisfy the equation of the circle. It's just the center. It's the point you're measuring from to get all the other points. So because this definition has to do with distance, the distance from the center to any point at all on the circle is exactly r. And r is given by the distance between that point and, say, that point. The distance is given by the distance formula. So the distance formula and this thing are related somehow. This point here is the point h comma k. Right? And that is just an arbitrary point on the circle. I could just pick any point. I picked it kind of at a upper right from the center just because then everything's positive and it's a little more intuitive. But this works everywhere on the circle. That's the radius. The radius is the distance that we had before. So we've called it C, we've called it D, and now we're calling it R. It's the hypotenuse of a right triangle, right? For most positions. There's a few exceptions. Like if you're straight across here, it's not really a triangle, but the Pythagorean theorem still holds as long as you think of the opposite side as 0. Same thing, if you go vertical, same kind of thing happens. Okay, so I make a little right triangle there. And then by the distance formula, we know that x minus h, the quantity squared, plus y minus k, the quantity squared. If you add those and take the square root, you get the radius. Now notice x here, on the previous page with the distance formula, all four numbers were constants. Here, x and y are variables, but it still follows the same equation. You just have to, like temporarily fix x and y and don't let them move for a moment. Figure out what the distance is, and then you can let it move and figure out what the distance is again, etc. So that's kind of the sense in which x and h are variables. Okay, but you can get every single point on the circle using this formula. Everyone has to satisfy this formula. Now, usually we don't care for the square root, the radical sign too much on the right. So we usually just write it actually a little bit more like the Pythagorean theorem, a squared plus b squared equals c squared. So we'll usually write it with a radius squared like that. It's just simpler to compute. Maybe a little simpler to remember too. It really is just the Pythagorean theorem. So h is the x-coordinate, the first coordinate of the center, right? And so you're subtracting those two. K is the second one. So remember, it's the second coordinates minus each other and the first coordinates minus each other. And then don't forget to square them. A squared plus b squared. A squared plus b squared equals c squared. That's what's going on. Okay? So that is actually the general equation for a circle. And from that, you can read off what the center is. The center is going to be, well, where is this 0? You set that equal to 0 and solve, and you get the x-coordinate for the center. You set that equal to 0 and solve, and you get the y-coordinate for the center. See, this way of thinking of it, you'll never get these wrong, even if there's a plus x plus 3 equals 0, x equals minus 3. The x coordinate of the center is minus 3. So that's simple. And then here, just be very careful that you actually do the square root of the number that's sitting here. Because if that's 16, r is 4. If that's 3, r is the square root of 3, right? If this is, a lot of times if this is small, like 4 or 9, people, including myself, forget to do the square root. As soon as I got to here, the first thing I would do is find the radius. I probably didn't here, but the smart thing is to find the radius first, because you might be nervous about messing that up. And these two you shouldn't mess up. Okay. So that's a general formula, so you need to know that formula. That's a formula for a circle with center HK and radius R. So they call this the standard form for the equation of a circle. Notice it's actually a quadratic. The highest power of any of the variables is the 2. So it's still what we call a quadratic. All of these conic sections are all quadratics. Okay. Also notice that if r is supposed to be a positive number, it's a distance. Well, distance can be positive or 0, but if r is 0, it's just a point. It's not a circle. But that's not a bad thing. If it's just a point, that means that's the center. Right? So if you shrink this radius down to 0, you're shrinking this circle down to its center. So another way of thinking of what I just did to find the center is, if you put 0 in here for the radius, you get the center. And if a sum of two squares of real numbers is 0, then each one has to be 0. So it makes total sense to set this equal to 0 to find the x coordinate of the center, and set this equal to 0 to find the y coordinate of the center. That's where that idea actually comes from. This is the center is called the degenerate circle. Circle of radius 0, degenerate circle. They mentioned that on the video before this chapter, if you watch that. Degenerate circles. It's also a degenerate ellipse. A circle is a special kind of ellipse. It's just super symmetric, right? Okay, so but it's important to know standard form, because you know how they'll say, like, write this in standard form, and that's what they mean. The form that you can read off the center and the radius from. If this was all multiplied out, that would be a standard form for a quadratic, but not for a circle. A little confusing maybe, but just remember with circles they want it written this way. So I'm just noting here that if you set r equal to 0, that's actually the degenerate conic, which is the center of, which is just that single point. I put it in curly brackets because it's a set of points that we're interested in. So it's a set with one point in it. And that would be the center of the circle with a non-zero radius, but the same h and k.